Okay, we're going to do what we did with capacitors with resistors. And so we're going to be using these spools, which are copper and copper nickel of various sizes. So spool 1 is 10 meters at copper 22. That's a nice fat thick wire, should have low resistance. The next one is copper 28 gauge, 10 meters. That has a smaller diameter, and so it's going to have more resistance. This is copper 22, 20 meters. This is copper 28, 20 meters. So these two should have double the resistance of these two. And lastly, we have 10 meters of a copper-nickel combination, which should be the most resistive. So the idea is we take our multimeter and set it on resistance instead of capacitance. And because we have a lot of wire here, we want to measure what resistance the wire gives us. In this case, it's about 0.4. So whatever number we get when we do the spools, we would have to do a subtraction. So at that point, I take the first one and I put this across. Whoops. Put this across. And the reason I'm not touching them instead of doing this is because it's harder to handle. So if I've got everything correct, I should be reading the resistance across this one. And I'm reading roughly 0.8. So I would subtract off 0.2 or 3, whichever I decided on, and that would be my value. And then I go over to number 3, because that's the same gauge number, and measure 20. Then I would take this one, and I'd literally move across number 2. Because if I put 2 resistors in parallel, I reduce the total resistance, and it's going to be less than the smallest one. So essentially, in this way, by putting the wire across, I'd move spool 2 out of the circuit. Then I would simply come over here to the other side of spool 3, and I'd measure my resistance, which I'd expect to be roughly double once I did my subtraction of 0.3 than from my first number. I would then go from 30 to 40, and over here you have an example of 40. I come over here to spool 1, I skip spool 2, I come over to spool 3, so that's 30. I then jump over to spool 1 over here, and I've got 40. To get 50, I'd simply move to spool 3. You'll see diagrams in your PowerPoint for each of these. But I wanted to see the setup and look at the numbers as you go. Now you're going to do this for copper 22 gauge, 10, 20, 30, 40, 50. You're going to do for copper 28 gauge, 10, 20, 30, 40, 50. You're then going to measure the copper nickel, which happens to be the most resistive, like so. And that should be roughly in the range of between 15 and 20 ohms. And then we're going to take the 2 most resistance-filled ones, which is spool 5 and spool 4, and put them in series, where we add resistance, and parallel, where we add reciprocally. So if I want to do this in series, I merely start at 4. These 2 are wired together, so I've got 4 and 5 together. And what you see is 22.5 ohms. So this is roughly around 4. This is roughly around 18. So yeah, that works. Resistance adds in series. Now, how would I do this in parallel, like you and me holding hands together? I would put this wire over here, totally on spool 5, and you'll see it climbing up to 18. Then I'd take another wire, attach it to the other side of spool 4, and then clip it to the other side of spool 5, essentially holding hands. And what you see, the value is going to be lower than what spool 4 was. In this case, it's measuring 4.0. So all the data is in your spreadsheet on how to do this, but we wanted to show you the hookups. And I'm going to try and see if I can find an easy way for you to do this. The trouble is the multimeter is relatively expensive. You can find a cheap one for under $9, but it doesn't really work that well. To get one that would measure resistance is somewhere between $20 and $50. So for that reason, I'm not sure I can find a hands-on one, but I can play with that. Okay. We're then going to do the whole thing again with a dedicated setup known as a Wheatstone bridge, and that's the next video.